Section 2.6, Other Types of Equations. To begin with, we want to evaluate 8 to the 2/3. Now, a fractional or a rational exponent can be written in two ways. I'm going to write both of them here. I could write this as the cube root of 8 squared. Or I could write this as, these are both equivalent, or I could write this as the cube root of 8 squared. It actually doesn't matter which of those I do, but I need to have my index of my radical. My index is the denominator. Okay. And my exponent is my numerator. In either case, that is going to be true. As you can see, index is my denominator, exponent is my numerator. Now, whichever one of these is easiest will work best. So for this, I could say the cube root of 64, which I happen to know is 4. Okay, that works. Or I do know that the cube root of 8 is 2, so this is 2 squared, or 4. So in either case, we get an answer 4. So what that means, for example, too, is x to the 5/4 equals 32. What that means is this is the 4th root of x to the 5th equals 32. So what I can do from there is raise both sides to the 4th power. That will counteract. My 4th root. And that is, let's see, that'll be x to the 5th equals 1048576. And then I can take the 5th root of both sides. And let's see. The 5th root of that is 16. So x equals 16. Now, what I could have done instead, and I'm going to point this out in a couple of places. The 5/4 equals 32. What we could do is raise both sides to the reciprocal of the exponent that I currently have. Raise these to the 4/5, which will be precisely what I did in these steps over on the left. And the 4/5 power on 32 is the, let's see, that'll be the 5th root of 32 to the 4th, which is 2 to the 4th, which is 16. So x equals 16. Whichever of those is easiest or seems to make the most sense, that is the way that we want to do it. All right, number 3. 3x to the 3/4 equals x to the 1/2. What I'm going to go ahead and do, and again, you can do this two different ways, what I'm going to do is raise both sides of my equation to the 4th power. Okay, now I'm going to multiply exponents there, so this will be 81 x cubed equals x squared. Now, it's just a cubic equation, which I can solve by factoring. I'll subtract x squared from both sides. 81 x cubed minus x squared equals 0. Factoring an x squared out of both of those, I get 81x minus 1 equals 0. And setting each of those equal to 0, I get two solutions. X equals 0 and x equals 1 over 81. Now, this was a cubic, from what I determined right here. This was a cubic, so there should be 3 solutions. But this x squared equals 0, actually there are 2 solutions to that equation, 0 and 0. Okay, x equals 0 is what we call a double root, or a double solution. So in fact, there are 2 solutions. There are x equals 0 is 2 solutions, plus the third is the x equals 1 over 81. So there are, in total, 3 solutions. Now, I could have factored this, and I'm not going to do that here. But you could actually subtract the x to the 1/2 to the other side and then factor out an x to the 1/4. And that should give you the same solutions. Alright, example 4, we'll do the same method did on example 3. Subtract 80x squared from both sides. So this is 5x to the 4th minus 80x squared equals 0. Factoring that, we can factor out a 5x squared. That leaves with an x squared minus 16. And x squared minus 16 factors as x plus 4, x minus 4, as we saw in our last chapter. That is a difference of squares. Now setting each of those equal to 0. 5x squared equals 0. X plus 4 equals 0. X minus 4 equals 0. We come to find we have 3 solutions. Okay, dividing by 5, taking the square root, x equals 0, x equals negative 4, x equals positive 4. Now, in fact, there are actually 4 solutions. This is a double root, double solution, and we have a single solution for each of these. So we have 4 solutions to our 4th degree polynomial. All right, number 6, we're going to factor this one because we do have 4 terms. Factoring is the best way to go. I'm going to factor by grouping. So the first 2 have an x squared in common, which leaves us with an x plus 1. Now the second 2 terms, I can factor a negative 9 out of that. So negative 9, which will leave me with an x plus 1. And then factoring out our common binomial term, x plus 1, x squared minus 9. And then the x squared minus 9 is a difference of squares. So x plus 3, x minus 3. Now setting each of these equal to 0, x plus 1 equals 0, x plus 3 equals 0, x minus 3 equals 0. We have the solutions negative 1, negative 3, and positive 3. Moving on to number 6, we have a radical equation. All right. Solve the square root of 15 minus 2x equals x. Now we use this actually on, I believe it was problem 2. Yes, problem 2. We can remove a radical by raising it to the power of the index. If it's a 5th root, we raise it to the 5th power. If it's a cube root, we raise it to the 3rd power. In this case, a square root is an index of 2. So we'll raise both sides here to the 2nd power, giving us a 15 minus 2x, which is much simpler, but now we have equals x squared. All right, so now we'll just solve this like a quadratic. Let's go ahead and move all the terms. I'm going to move them to the right side. I'm going to rearrange this quite a bit. Okay, but I'm going to have x squared plus 2x minus 15. X squared plus 2x minus 15. All right, and I'm doing that so that I have a positive x squared term, so that I can potentially factor this. All right, so this will factor as x plus 5 and x minus 3. Yes, that will work. Okay, setting each of those equal to 0, we see that our solutions are x equals negative 5 and positive 3. Now, the only problem with raising an expression like this, eliminating the radical by raising it to the 2nd power, is that we actually could potentially introduce something called an extraneous solution, which means one or more of these proposed solutions may not actually make the equation true. So we want to go back and test each of these. X was negative 5, 15 minus 2 times negative 5 equals, in this case, x equals negative 5. Square root of 15 plus 10, that's 25, which is 5. Is that equal to negative 5? No. So x equals negative 5 is, again, what I would call an extraneous solution. All right, that one's not true. How about x equals 3? Let's check that one. Square root of 15 minus 2 times 3 equals 3, our x value. This is the square root of 9, which is 3, and that is in fact equal to 3, and so our solution, the only solution, is x equals 3. All right, number 7. Here we have two radicals. So it is worth noting, again, that we have two radicals. That's a big deal. What we are going to do is isolate one of these radicals. So how I'm going to do this is I'm going to write this as the square root of 2x plus 3, and then we can actually use our tactic from the previous problem, 4 minus the square root of x minus 2. Okay, I'm going to raise both sides of my equation to the second power. Now the first of these is fairly simple, 2x plus 3. However, the second side is actually 4 minus, I'm going to go ahead and write this in here, 4 minus square root of x minus 2 times 4 minus the square root of x minus 2. It is that expression multiplied by itself, which would be 16. And then we should get minus 8 square root of x minus 2 plus x minus 2. In that third term, the square roots cancel. We're squaring a square root. Okay. We've still got a radical in this, so we're going to rearrange this. I'm going to move everything to the left side except for that square root. All right, so if we subtract an x, that will be an x. Subtracting, well, the 16 and the 2 means 14, so we're subtracting 14. So minus 11 equals negative 8 square root of x minus 2. And now we will take both of these to the second power. And again, we could potentially have extraneous solutions here, so we want to be very careful. So this is x squared minus 22x plus 121 equals 64 times x minus 2, which is 64 minus 128. Alright, moving all that onto one side, we have, add the x there, we will have an x squared minus 86x plus 249 equals 0. Okay, this is quite a good deal more complicated. Okay, now I don't immediately see that this is going to factor, so what I'm going to do is use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. Right, all divided by 2a. So 86 plus or minus something, square root of something, over 2. And inside that square root, our discriminant there is 6,400. So there are two solutions. And the square root of 6,400 is 80. So this is 86 plus or minus 80 over 2. So our solutions are 86 plus 80 over 2, which would be 83. And 86 minus 80, which is 6 divided by 2, so 3. Now, we will have to plug both of those back in to check. All right, well, maybe not do all this the same way. Let's go ahead and plug in the 83. 2 times 83 plus 3. Square root of that is, so that is 169, so that is, square root of that is 13. Plugging in 83 here, square root of 81 is 9, so 13 plus 9 is 22. Okay, that does not work. Okay, now plugging in 3. Okay, so this is an extraneous solution. Alright, so if I take 3 and plug that in, 3 times 2 is 6, so that's the square root of 9, which is 3, plus the square root of 1, which is 1, and that is in fact 4. So x equals 3 is our solution. All right, number 8, we have some absolute value equations. If you notice, we have absolute value of 6x plus 4 equals 8. Absolute value is on that quantity there. Now, the absolute value is always positive. Okay, the output of the absolute value is always positive. It's the distance a number is from 0. So, if we have equal to and we have something that is greater than 0, that means we have two solutions. Okay, because that is going to be positive. So there are two solutions to this equation. Those solutions are exactly when 6x plus 4 equals 8 and when 6x plus 4 equals negative 8. Because potentially the absolute value of negative 8 is 8, the absolute value of 8 is 8 as well. So if we solve both of those, well, the first one is going to be 2/3, subtracting 4, dividing by 6. And the other, subtracting 4, we get negative 12 divided by 6, x is negative 2. There are our two solutions. All right, part B. The absolute value of 3x plus 4 is equal to negative 9. Well, when this is less than 0, because the absolute value is always positive, it's the distance from 0, if it's less than 0, we have no solutions. None. Right, so part B, just go ahead and label that no solution. All right, part C. Absolute value of 3x minus 4, quantity, minus 4 equals 6. Well, first we need to get our absolute value alone, so 3x minus 4. I'm going to add 4 to both sides, so equals 10. Well, in that case, this is greater than 0. Okay. 10 is greater than 0. So we have two solutions, where 3x minus 4 equals 10, and where 3x minus 4 equals negative 10. Adding 4 to both sides, 14/3, x equals 14/3. And the other, negative 6, so that will be, adding 4 to that is negative 6, divided by 3 is negative 2. So x equals 14/3, and x could equal negative 2. All right, well, part D, we have equals 0, so there is one solution. Okay, I want to make sure you remember this. This is something we want to check as we're going. So there's one solution, and that is when negative 5x plus 10 equals 0. Subtracting 10 from both sides, dividing by negative 5, x equals 2. All right, number 9. 3x to the 4th minus 2x squared minus 1 equals 0. Now, this is in what we call quadratic form. Quadratic form. We have an exponent, a leading coefficient here, or leading term, with an exponent that is double the middle term, and we have a constant here. Okay, it kind of looks like a quadratic. In fact, we can make that look even more like a quadratic by making a substitution. I'm going to say u equals x squared. Based on our properties of exponents, this is 3u squared minus 2u minus 1 equals 0. Well, now it's just a quadratic. So why don't we solve that? Now, one thing we want to notice here, though, is that our original equation was a 4th degree polynomial, whereas our new polynomial in u, in terms of u, is a 2nd degree polynomial. So in the end, there should be exactly four solutions. Whether they are real or imaginary, we should have 4 solutions. I'm going to go ahead and just use the quadratic formula for this. So this would be u equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So that is 2 plus or minus the square root of something over 6. And that would be, well, negative 2 squared is 4, plus 12, 16. So this is 2 plus or minus 4 over 6, which means that u is 6 divided by 6, 1, or 2 minus 4 is negative 2, so that's negative 1/3. Great, we know what u is. However, we want to know what x is. So we're going to go back to our substitution there of u equals x squared, and this is x squared equals 1. X squared equals negative 1/3. Alright, well, solving the first equation, we see that x equals plus or minus 1. In the second equation, x equals plus or minus I, and the square root of 1/3 is 1 over square root of 3, so we'll go ahead and write it. Actually, let's not. Let's write that as 1, or I, times 1 over square root of 3. Now another way to write that would be x equals plus or minus I times root 3 over 3. Multiplying by square root of 3 over square root of 3. And so our four solutions are these right here. So it originally had 4 solutions. We turned it into a quadratic, okay, so that we could use the quadratic formula on it. But in the end, we used that substitution, u equals x squared, to find our 4 solutions there. We'll pull a similar trick for number 10. This is in quadratic form if only we didn't have the x plus 2 squared. So let's go ahead and make u equal to x plus 2. Okay, if u is equal to x plus 2, then this is u squared plus 11u minus 12 equals 0. And that is a quadratic that factors. As, let's see, we're going to have 2 u's there. We're going to have a 12 and a 1. One of them must be negative. Let's make that a negative 1 and a positive 12, which setting each of those equal to 0. In fact, I should probably go ahead and do that. U plus 12 equals 0, u minus 1 equals 0, u is negative 12, u equals 1. Okay. Well, we want to know what x is, so u equals x plus 2, so that is x plus 2 equals negative 12, x plus 2 equals 1. So solving each of those, x equals negative 14 or negative 1. And there are our 2 solutions. Now, originally we had a quadratic. We converted it to another form of a quadratic, and so we still only have 2 solutions. All right, number 11. This is actually a rational equation, and we dealt with rational expressions in the last chapter. So what we're going to do is first factor anything that we can. I'm going to factor everything I can. So negative 4x over x minus 1, that does not factor. Plus 4 over x plus 1 doesn't factor. However, the denominator on the far right does. This would be x plus 1, x minus 1. What we're going to do is clear our fractions. Okay, I'm going to multiply every expression in this by the least common multiple of my denominators. In this case, that is x plus 1 times x minus 1. I'm going to multiply everything by that, and hopefully you will see what happens there. When I distribute that, I'm going to multiply both of these times each term here. I'm actually going to multiply them in the numerators. Okay. So this is negative 4x, okay, times x plus 1 times x minus 1 over x minus 1 plus 4 times x plus 1, x minus 1 over x plus 1 equals negative 8 times x plus 1, x minus 1 over x plus 1, x minus 1. Several things are going to cancel. Now, before I cancel anything, I want to notice that my x values cannot be 1 or -1, because that would mean I am dividing by 0 in one of these places. So note that I cannot have an x value of 1 or -1. Those are called my domain restrictions. Okay. Now what happens here is several things cancel out. My x minus 1 term cancels out here. My x plus 1 term cancels out here. And here the x plus 1 and the x minus 1 cancel out, leaving us with -4x times x plus 1 plus 4 times x minus 1 equals -8. We now have a quadratic. We reduce this down to a quadratic. So multiplying this out, we get -4x squared minus 4x plus 4x minus 4 equals -8. Combining like terms, we get -4x squared minus 4 equals -8. And we can actually solve this by square roots, adding 4 to both sides gives us a -4 on the left. -4x squared dividing by -4. We have x squared equals +1. Taking the square root of both sides, we get solutions of x equals plus or minus 1. Now I'd like to draw your attention to our domain restriction that we stated previously. X cannot be 1 or -1. Both of these are in fact extraneous solutions. Extraneous solutions. So this problem has no solution, or there are no solutions to that equation. Alright, that brings us to the end of this section on other types of equations. There were lots of types that we've seen in here. We've seen radical equations in which we can raise both sides of our equation to a particularly chosen exponent. To remove them, a cube root, we raise it to the third power, a square root, we raise it to the second power, etc. We've seen rational equations that we just have right here, where our trick that we pull is multiplying by the least common denominator of all of the fractions there. And we've also seen some in quadratic form. Okay, so recognize them when they are in each of those forms and sort of use the tricks or the direction, the plan that we have used here.